Reflex-1. Scatter plot and correlation. Scatter plots or scatter diagrams, scatter chart, or scatter graph are used to show relationships between two variables. The values of the variables are represented by dots, and a scatter plot is drawn with the independent variable on the horizontal axis and the dependent variable on the vertical axis. For example, the table below shows the relationship between a person's annual salary X and his or her car price Y. Verify the data points are at the correct spot in the graph. Let's check the first entry here. When the salary is $55,000, the car price is correlated to $19,500. So that would be this first point there. Yep, that looks about right. The second entry, we have $58,000 for salary and $20,000 for the car, and that would be the second dot right here. That looks about right. The third entry, $62,000 for the salary and $25,250 for the car price. So that would be this point right here. Looks right. The next entry, $78,000 for the salary. $78,000, yeah, looks about right. And $35,000 for the car. Yep, so that's good. One more, $100,650 correlated to $45,000 car. All right, $45,000 car. Yep, and over 100,000. That's about right. One more entry, $130,500 salary correlated to $62,500 car. So that would be this point, and that's correct. Done. Now let's talk about correlation and the types of correlations. And the first type is what we call the positive correlation. As one variable increases, the other variable also increases. And we use the letter R being greater than 0 to indicate a positive correlation. For example, the scatter plot we have right here is an example of a strong positive correlation because as one variable increases, the other one also increases. And the next type of correlation is what we call a negative correlation. As one variable increases, the other variable decreases, and we use the letter R being less than 0 to indicate a negative correlation. For example, the scatter plot shown here is an example of a strong negative correlation. As one variable increases this way, the other variable actually decreases. And the next type is the positive exponential correlation, where an exponential curve can be fitted to the data points. And the next type here is the positive quadratic correlation, where a parabola can be fitted to the data points. And finally, we have a none or weak correlation, where there's no apparent connection between the two variables, and therefore no line or curve can be fitted to the data point. And we'll use the letter R being 0 or R is near 0 to indicate this weak correlation. Note that the strength of the linear relationship increases as R moves away from 0 toward either -1 or 1, and if the coefficient of the correlation is R is equal to 1 or R is equal to -1, then there is a perfect linear relationship. And guess what? We have a nice table here that shows the strength of a relationship relative to different values of R. So if the absolute value of R is less than 0.3, in other words, if the value is very close to 0, then the strength of the relationship is classified as none or very weak because the R value is very close to 0. Now, if the value is between 0.3 and 0.5, then it's still a weak relationship. And next up, we have the value between 0.5 and 0.7, and this is what we call a moderate relationship. But if the value is above 0.7, then that is a strong relationship or a strong correlation. And it's time for some exercises. Number 1, in a survey, researchers asked the participants how many hours they sleep in a day and recorded the data in the graph to the left. What is the approximate age of the participant who required the least amount of sleep in a day? Okay, the least amount of sleep. We have the amount of sleep on the vertical axis. That means we're looking for the least amount, which is this dot right here, corresponding to a little below 8 hours. And that's almost at the age of 12. So the approximate age of that person is 12. Done. Number 2, the scatter plot shows the number of products in a box and the price of each box. If A, B, C, and D are the names of the products, which has the best unit price? Okay, remember the unit price is equal to price divided by the number of units. Now, in order to get the best unit price or the lowest unit price, we want the top to be as small as possible and the bottom to be as big as possible. So it looks like point D here would be our choice, because if you line up the value for price, it's pretty low there, and the number of products is the highest. Therefore, D would be our choice. Done. Number 3, which of the following graphs best shows a weak positive correlation between X and Y? We can immediately eliminate C and D because these are negative correlations, because as one variable increases in size, the other one actually decreases. Now, between A and B, A has a strong positive correlation because all the dots are pretty compact together, so it's not A. And B is our answer, because as one variable increases, the other one does increase a little bit, but the dots are not very compact together. So this is a weak positive correlation. Choice B. Done.